spectators. So initially at the time, last July, actually the first meeting was last July. So I somehow hesitated to accept his proposal or not, because building this robot looks like somehow simple toy job. But later I realized that wow, there are a lot of research issues in here. Well, I mean, I put it here for the group intelligence. It means a thinking of school fish. Group intelligence, I mean, multi-unit system concept can be applied here. So a lot of research issues are involved here. And also, the key purpose of this project is to have some interaction with the human spectators. If the real fish, if it is a real fish, and then spectators may be enjoy fish, even if you are trying to make it like a living, real fish, but the spectators may not be satisfied. Initially they will be surprised, but later disappointed and may not be coming back again. So the idea, the key purpose, key objective in this project is to have some interactions with the humans out of the work container. So that is the my research direction. And now we, after some initial talks and some selection process, finally we started this project last December. And after some basic trials, we developed this robotic fish. So we are tuning some proper parameters. So this for higher speed, and this one is somehow smoother behavior. So we have robot head last week. So by the end of May, we will finalize this project. And then, I mean, for one fish, later we will build more fishes, and then we will put some idea into here for the multiple robot coordinate behavior. So for performance. That's the point. Thinking of, for example, 5 fish robots, robotic fish in the water container, they should be very coordinated to have to show some performance to the audience. For the purpose, I think it's still starting point that we finished the first initial experiments. I mean, waterproof is one of the key issues in here in waterproof, but we finished. So if I chance to come back here again, I hope I can show you the final version of this robotic fish. To show some different types of fishes, and we are aiming for this category. Now this one is the genetic intelligence. This one is mainly for showing some specific personality, some characteristics for the purpose. This internal state, the range between perception information and internal states should be very coordinated for the probability, even if somebody was having the picture, the change of internal state may be different from each other. So by using some different rating system between here and here, you can expect different characteristics. So at the time, defined some robotic genome. This is the chromosome consisting of fundamental state-related genes and behavior-related genes. If a specific gene in this category is a higher value, and this behavior seems to be some more active, or if the internal gene in here in this category, the gene value is less than less, and then its expected behavior, the internal state seems to be different from each other. So this is the chromosome, and by combining these chromosomes at the time, I provide 14 chromosomes. Okay, this one is the robot genome. So the background. the higher value. Red one is the negative value. So we don't have to think of the complementary part. We don't have to think of double strand and double helix structure because it's a computer system. So the copied version can be easily obtained by copying this one. We have this complementary. But anyhow, we are dealing with computer world, so we don't have to. Anyhow, in this research, I don't have to think of the double helix structure. So C1, C2, 14, for instance. So to build a truly believable emotional artificial creature, personality is really significant. As you mentioned, personality is the engine of behavior. I mean, depending on its personality, expected behavior might be different. So, proper genome for a personality is needed to give rise to the meaningful behavior. However, non-linear phenotype generalization, so quite difficult to understand. So, dependent code is very much difficult. So, it needs many functions the system. So, genetic representation and evolution technologies are required to generate a plausible creature. Okay. For this purpose, I published on 8 and 9 about this one. At the time, I named it evolutionary generative process for personality. So I provide two genomes, two set of genomes. One is the agreeability. The name is Riti, and this is the antagonist Riti. And then this shows the different characteristics. You can easily see which one is agreeable and which one is the antagonist. Definitely, this one is agreeable. So looks so happy and very mild and following the command quite gently. However, this one is quite sensitive. I mean, one click is petting, double click means hitting, kind of punishment. So if you double click here, this guy, and very much sensitive, angry was applied. However, this one is this gives extra command, move forward. So you can see the difference of two artificial creatures depending on its internal information. So this is the conclusion.
This walking gearbox pretty much does what he's told. A sophisticated machine, but not much personality. Designing a truly intelligent robot, one that can think and feel on its own, is the holy grail for robotics scientists. And at this South Korean lab, they believe they're creating nothing less than the origin of artificial species, Charles Darwin 2.0.
Evolutionary concept has been used in engineering field. So motivated by Charles Darwin, I thought of artificial genome for robots. This is internal architecture.
Far-fetched? Not for renowned robotics expert Kim Jong-hwan. Professor Kim is best known for creating the Federation of International Robot Soccer, where droids battle it out on the pitch. His latest project focuses not on the brawn, but on the brain, a robot with human qualities and feelings, with a design based on genetics.
Emotion means here happiness and angriness, or fear and sadness.
Meet Gritty, a cute puppy avatar who's a lot more complex than he appears. Kim calls it a sobot, or software robot. He's programmed with artificial chromosomes to create human personality traits.
This is the software robot in a virtual world. As you can see, it has its own emotions. So right now it is quite sad.
Like a genie in a lamp, he springs to life when stimulated. The software robot can even move from machine to machine at will, or to the body of another bot. He shows 77 different behavior patterns, more than you can say for one of his conventional cousins. This robot may act like a real dog, but a sobot takes it one step further. It's actually trained to recognize its master. All I have to do is turn to this camera, and in an instant, he knows exactly who I am. And pretty soon, he won't leave me alone. A human-like robot may seem downright creepy.